Hi guys, welcome to this YouTube tutorial video. We'll be looking at physical sciences chemistry. The topic is organic chemistry and the subtopic is organic reactions. So now we'll be looking at substitution reaction. This is part 2 out of the 4 sequel that we're creating. Now let us look at what substitution reactions are. Remember, whenever you substitute something, it means you replace it with another, right? So now here's some background theory about substitution reactions. It says it takes place when saturated compounds, remember saturated compounds, these ones have single bonds, right? It takes place when saturated compounds react and an atom bonded to the carbon chain is substituted by another atom or another group of atoms. So the reason why we are substituting, remember carbon has a maximum of 4 bonds, right, in its saturated nature. So if you have it as a saturated compound, you cannot add another bond. Let's take this simple carbon here, which is methane. Single bonds only, meaning it's an alkane. So you can't add anything to this. So this one definitely won't undergo additional reaction. It can only undergo substitution reaction, meaning we'll be replacing one of the hydrogen atoms with any other atom. So we are producing products that are also saturated. Like we said, we are taking it from its saturated nature, just replacing something by something, leaving us with another saturated compound. Are slow, and lastly it says that are not spontaneous. So since they are not spontaneous, we must add energy into the system. Let us look at the first kind of substitution reaction. So in this one we are looking we are forming haloalkanes or alkyl halides from alkanes. Remember, alkanes are saturated compounds, so we cannot add anything into this, we'd rather substitute. So the first type of reaction is halogenation again. It says it's an endothermic reaction, meaning heat must be supplied. So we need energy must be supplied into the system, right? So it's an alkane reacting with the halogen. Remember, what are halogens? Halogens were said to be the group 17 atoms, right? Be it all of them are diatomic. You had your chlorine, you had your bromine, you had your fluorine, and then lastly you had your iodine, right, to form that product there. So alkanes react with halogens, these ones, bromine, chlorine, but remember that they are diatomic. So alkanes react with halogens when heated, indicated with delta there, representing heat added into the system, or in the presence of light. So light is represented by that HF there. The reaction adds a halogen atom to the molecule, so it is known as halogenation. So let's look at the first one. First problem says write a balanced reaction for the reaction of methane with chlorine gas. Remember methane, how do we write methane? Methane is meth, right? And it's an alkane, so we have only one carbon atom bonded to 4 hydrogen atoms, and then this reacts with what? We told us it's chlorine gas. Chlorine gas, that's diatomic, right? But we can break it down so that we have a chlorine bonded to a chlorine, and then we get the products. What? We get the products. Remember, heat must be added into the system. So now we should substitute. One of these 2 chlorine atoms is going to replace one of the hydrogen atoms there. So let's say we are replacing this one. We have this product now. First hydrogen, second, third, and then we have the chlorine atom. Now we only have, since we took this one and substituted it there, what happened to the hydrogen? The hydrogen will then bond with the remaining chlorine atom to give us what? To give us H bonded to Cl, just like that. So if we name it, we have methane that bonded that reacted with the chlorine gas to give us that. What do we call this product? Now this is a haloalkane. We see the halogen there and it's single bonds throughout, so it's 1 chloromethane. but it's pointless to say 1-chloromethane because even if you put that chlorine atom anywhere there, it still gives you the same product. So it's still okay to say it's chloromethane. Plus, remember, this is what? There's two ways to name that one. It can be hydrogen chloride, or the most common name, which is hydrochloric acid. And then now let us look at another one. There's one rule which applies on elimination reactions. It's for elimination reactions. I think we can also apply it here on substitution reactions. It's the rule that was proposed by this guy known as Zeitzer. So it's Zeitzer's rule of elimination, but remember now we are dealing with substitution reaction. So Zeitzer rule simply says that if you have an asymmetrical organic compound, you will take from the one with less hydrogen atoms. Let's say now it's a reaction between let's take propane. It's a reaction between propane and bromine now. So if you look at this, propane has 3 carbon atoms. So you have that, and it's a saturated compound. Since it's a saturated compound, you can no longer add anything here. All the bonds are occupied. What can you do? You can only substitute. So this reacts with Br bonded to Br. Now, let us look at this. I have 3 options. I can take from this carbon atom, take that hydrogen. Or I can take that hydrogen atom or that one. Remember, we are substituting. So I can either substitute carbon number 1, number 2, number 3. So now the rule that was proposed by Zeitzer simply says that it's actually the opposite of Markovnikov's rule. Remember that Markovnikov's rule says that you should add to the carbon atom that already has more hydrogen atoms, right? But now with Zeitzer rule says that the one with less hydrogen atoms is the one you are going to take from. And this rule applies more on elimination reactions. So I think we can also apply it on substitution reactions. Because if you look at this, say I were to take from carbon number 1, which is the same as taking from carbon number 3, I would get a product which is something like that now. C bonded to C, and then I have this, that, and then I have the bromine here, and then the last product being plus HBr. Remember, we're substituting. We took this hydrogen atom, replaced it by that, and where did the hydrogen atom go? It went to that Br to form that product there. So now if you look at this, when we take from carbon number 1 or carbon number 3, we have 1 bromopropane. That's the product we get. But now what if we took from the one which is on the middle? If we take from the one in the middle, we now get a product that looks something like that, whereby now we have the bromine in the middle carbon atom. And then now this is different. This gives us 2 bromopropane. Now question is, which one between the two is correct? If we follow that rule, which is for elimination reaction, it simply tells us that the correct one has to be the one on B, because it says you should take from the carbon atom that has less hydrogen atoms, and in this case it's this one. It only has 2 while the other one have 3, both of them, right? And remember, taking from this one is the same as taking from this one, because it's 1, 2, 3. If I'm counting from the right to the left, it's still 1, 2, 3. So the only difference is that this one is still correct, but it will depend on the question. If they want the major product, so I'm confident that you have to apply that rule there. Okay. Yes. Let us move on. Then we have reactions of bases with haloalkanes to produce alcohol. So now we are producing alcohols. Remember, haloalkanes are saturated compounds. Alcohols are also saturated compounds. So you have this process, hydrolysis, right? So it comes in 2 ways now. We can either take a haloalkane and add water to produce an alcohol, or we can take a haloalkane and then add a diluted strong base to get an alcohol and that compound there. So now let's look at it. It's a haloalkane plus water to produce alcohol, and a hydrohalogen. Remember that X there represents a halogen. It can be fluorine, chlorine, bromine, or iodine, right? It's a reaction with water. Remember, heat must be added to the system because these reactions are not spontaneous. The haloalkane must first be dissolved in ethanol. This one makes it dilute, so we are diluting it before the reaction. The reaction is slower than the reaction between haloalkane and a strong base. Okay, we don't really need that information. So let us do this. Write an equation for the reaction between chloroethane with a dilute sodium hydroxide. So we have chloroethane. How do we write chloroethane? Chloroethane has 2 carbon atoms, so it's meth, and then we have the hydrogen atoms there. It's chloro, so we need a chlorine atom. We have chlorine, and then we have only hydrogen surrounding that one. Even if we wrote this on the other side, it's still the same. If we're counting from left to right, it's 1, 2. From right to left, it's still 1, 2. And then it reacts with the dilute sodium hydroxide, so it's plus sodium hydroxide. Remember, we can split sodium hydroxide such that now it becomes sodium plus hydroxide. We need that hydroxide group there. And then, no, let's not say plus, it's bonded to that. And then the reaction, we have what now? We have this one. This is what produces the alcohol. Remember, hydroxide. Alcohol has a hydroxide group. Must substitute that. So now finally we have C, we have an H, and then instead of having the chlorine, now you have an OH there, plus. Then what happens to that Cl there, the chlorine atom? It then bonds with what's remaining on the other side. So that's NaCl. And this reaction is self-balanced. So we're just going to name the products. We know this one to produce what? Produce this compound, which is an alcohol. But what kind of an alcohol? If we represent the position of the hydroxide, even if you write the hydroxide on the first carbon atom or the second one, it's still no difference. Plus, and then we have that. What's that? It's sodium chloride. Okay, and this one is pretty much simple. You just need to locate the haloalkane and then substitute it with the hydroxide. Write an equation for the reaction between 1 bromopropane. So we have bromopropane reacting with water now. 1 bromopropane, remember prop is 3, 2, 3. They represented the location of the bromine, which is on carbon number 1. So we have Br, it's a saturated compound, only single bonds. So we have that. It reacts with water. So it's H bonded to OH. Remember, we're looking for that hydroxide because we are producing an alcohol. So what do we get? First things first, we substitute this by that to get this now. So that this is hydroxide plus, and then as soon as we took this, we substituted there. What happened to this? It's going to react with that, so it becomes HBr. And what's that? It's a haloalkane. It's hydrogen bromide. Hydrogen bromide, right? And then what's this now? This is an alcohol. Normally it has to be a propanol because it has 3 carbon atoms. But because we must locate the position of the hydroxide group, then it becomes propan 1-ol, right? So that's pretty much it with substitution reactions.